Okay, so my clock has 10 o'clock second lifetime. Well, epic maybe because of all the people we know and stuff. Okay, so anyway, I'm going to get started. I like to try to go about an hour. As I said, you're welcome to chat and stuff. Usually it's only the presenter that uses voice. So anyway, I am extremely fortunate. Yeah. Okay. So I'm extremely fortunate to be in an area of the world right now where there were two eclipses that passed, or there's one that passed over my house last October, and there's a total eclipse that is going to pass over my house on April 8th. And that's extremely rare to have that happen. It's only about once in every 300 years. And I don't think I'm going to live that long, so it's kind of a once in a lifetime thing. So I don't have to go anywhere. I'm, by the way, if you happen to be in the area in central Texas, let me know. Shut the door. Okay, yeah, the one in October was what's called an annular. Okay, does anyone know? And I also like to ask questions so that I know if everybody's awake or up getting a cup of coffee. Is the difference between an annular and a partial and a total eclipse? Anybody want to hazard a guess there? I have some astronomers in the audience, so So what do we got? Well, yeah, people are going to try to scalp. So yeah, okay. So in other words, with a annular, the moon's apparent size is not quite big enough to cover the whole sun. So you have a little ring around there that is still the sun. Yeah, Cass, for sure. Cass is a practicing astronomer. Okay, and yeah, the moon passed in front of the part. Now, okay, with a partial eclipse, that's right. In other words, the path of the moon, the path of the sun are a little off, but one of the shadow passes over part of the Earth, so you get a partial one, and then total is a fairly rare event because the size of the moon is actually larger than the size of the sun, so it literally blots out the sun. Okay, okay, let's take a look then so today I'm going to talk about solar eclipses and myths and predictions over thousands of years. Most of my talk will have to do with what people thought a couple thousand years ago, or learned a couple thousand years ago. Yeah, okay. Dolly. The other thing is, frankly, there is such a thing as a hybrid eclipse. I didn't know there was, but under really rare conditions, a eclipse can turn from annular to total or total to annular over its path. Okay, so yeah, okay, so this is what I'm hoping to see in April, just sitting outside on my porch. And yes, okay, that's what's called the diamond ring effect. That just because the moon, does anyone happen to know now? Frankly, there's lots of different talks that I could make having to do with the material in this presentation. But does anyone happen to know why you have a diamond ring effect? That's a little bit odder. Okay, so maybe Sis, there's a few people here, but the diamond ring effect, if I'm not mistaken, yeah, okay, off center a little bit, but diamonds are good. Okay, it is, yeah. Now I will talk a little bit about the um, eye protection thing, but this particular presentation is more on how do we predict them rather than the safety effects. Well, okay, there you go, sumo. The moon is not, as people thought 2,000 years ago, perfect sphere. It has valleys and mountains and stuff, and what you're actually seeing is the moon coming through. If the moon apparent size is pretty close to the sun, you'll get the sun coming through some of those valleys and stuff. It's kind of a very rare thing. So I'm hoping to see a this with maybe a diamond ring effect. Okay, so what have we believed about solar eclipses? So in other words, the topic today is both myths. Now, I wanted to change that to beliefs because a myth is, for one people, is doctrine to another. So it just depends on what you believe. So, good one, says. Okay, the old beliefs for eclipse. Okay, but we have beliefs today about the sun. So I'm going to share at first some of the types of things we have and still believe about eclipses because they're pretty rare, at least in one particular area. In other words, they're somewhat of a lifetime event in one area. Okay, so the first thing, kind of some of the myths. Okay, by the way, let me just say up forward that you should never, ever stare at the sun for long. And I mean, you know, a couple seconds. Because even a couple seconds you could burn. It's very bright, and it can burn the back of your eye permanently, and you don't want that, obviously, because your eye focuses things, for one. And so the only time that it's safe to well, there's that. I haven't asked it. Okay, but the only time it's safe to look at the sun ever is for any length of time is during the middle of a total eclipse. That is not the diamond ring thing, but the entire sun covered. And then that's the only time that you can take off like solar glasses, etc., to look at it, because the sun itself is completely covered. What you're seeing is the corona on the outside. Okay, so there were two basic stories that people had over thousands of years about why there's what is happening with a solar eclipse. And they basically vary, and it didn't say whether, one was made up by men and one was made up by women, but I kind of think maybe the first one was made up by guys and the second one's made up by women. But, it's the old attack and parry thing for the guys. But essentially, for the Vikings, it was Loki was, the trickster Loki was being chained up, and then he got loose and he made these giant wolf creatures to chase the sun and the moon and occasionally to catch them and eat them. And then there were other ones like in Peru and other places where they thought, oh, we need to help the sun, so they shoot arrows in order to scare away the beasts attacking the sun, or in some cases to relight the sun. I watched. Okay, now what I've heard says is you need to watch that one. In other words, I Google whether arc welding filters are okay. I read that not so much yet. In other words, I wouldn't try it. We've got arc welding things, but I'm not an expert on that part. In other words, I'm not going to say yes or no. Okay, so the other one is in Indonesia and other places. In India, they believed it was a demon. And I put the Indonesia one because I thought that was cool. Is the demon's attacking the sun, but then spits it out. In other words, you have to explain why the sun then comes back. Well, yeah, you have to be careful about why somebody does it on TikTok. I wouldn't believe much of anything. Okay, now I'm 10 minutes in, so I want to keep moving on here because my primary thing is about how to predict. Okay, so you can kind of read the other stuff. In other words, they're having a romantic union. So you got either the female sun and male moon, or the male sun and female moon, and I think that's kind of cool. The one I like is the Tahiti one, where the lovers get lost in the moment and need the stars to light their way back, because during a total eclipse you're able to see the stars. And it actually gets cool, and the animals react to it. It's most cool. I've never experienced one. Okay, so anyway, now, other people believe that the eclipse can actually do things to you or have either negative or positive effects. Down in the positive, most of them are negative effects, but down in the positive, you've got that basically, like the Native Americans, some believe that the sun and moon were kind of off checking on how things are going on Earth. I like that. Stellar endorsement. Okay. But there was also, and I thought the Alaskan Japanese one were interesting because of it could have gone back really, really far to where the people in Alaska that came from Asia thousands of years ago, maybe this story came from long, long time ago too, but the idea that there might be dew or rain that causes sickness or poisons the wells. And of course, there were a lot of explanations for the plague. Okay, now I actually looked this up on Google. You know, what do you do during the eclipse? And it's amazing. There are a lot of people that still believe that the eclipse does things. So I found one from the Indian Times of Economic Times of India. I found one on a local radio station. I found one from Arizona. Lots of different things. Is it safe for vampires? Only for a few minutes. But Tag, you have to look that one up. That's a very funny one. Okay. Yeah, for 3 or 4 minutes. Okay, and then they'll burn up. Okay, so anyway, even today they've got cautions on online and in newspapers and stuff where it says, okay, women, particularly if you're expecting a kid, wear something red, wear a safety pin, don't keep sharp objects around, stay inside, all this stuff. And then other people go, okay, it's a very powerful time, so set out containers of water. And then you can use them when you're feeling sick or in cooking or on your plants or all that good stuff like that. So I thought that was very interesting that there are still beliefs about eclipses. And also that basically it runs common. In other words, some of these stories may go back thousands of years because they're very common around the world in different cultures. I always love it when you've got some of the same stories or almost same stories with modifications coming from different places in the world. Okay, now, one of the things that for people that observed what was going on was that they found very early on, of course, thousands of years ago, that events in the heavens, in the skies, actually did foretell things on Earth. In other words, of course, the solar cycles foretell the seasons, which mean, you know, when do you plant, when do you harvest, that sort of thing. Different moons, like, you know, the hunter moon and the whatever types of moons. Yeah, oh heavens. Migrations of travelers. Yeah, that's funny. You know, actually, the largest city in the area where I live within about, I don't know, a couple hundred kilometers is only, or 150 kilometers, is only about 20,000. They're expecting about 100,000 people to show up for the one on April 8th. And millions of people traveling to see a glimpse of total eclipse, which is amazing in 2024. Okay, so it really does, things up in the heavens really do foretell events in a million people. Yeah, okay, there you go. And I appreciate that the mythical dogs called Bulgay. Good. Okay, I love to hear one of the reasons I like to talk to people in Second Life is because it's not the tiny little dot on the map where I live. It's people from all over the world. So I love to hear from different parts of the world. Oh my goodness, you up in Maine and stuff? Okay. Now, I was hosting I told you, if you're in my area, let me know, but I was hosting a well-known person in Second Life, was going to come visit in April, but his wife talked him into a vacation in Mexico, which is also in the path of totality. So I think they probably have the better deal there. But okay, so anyway, the solar and lunar cycles do foretell the tides, which affect fishing and boat transport and such, and floods. Like you probably know about when Sirius is the dog star is rising during the dog days of summer. Basically foretold that the Nile would flood, and then the Mayans and cycles of Venus and solar eclipses foretelling the future of Emperor in China, all those sorts of things. So what if we could predict them? Well, we can predict some of them, of course. The solar lunar cycles are the basis of calendars, but could we predict an eclipse? I'm going to say yes, because I'm going to show you how they did it. Okay, I'm just typing in something here for a second. This year. Okay, so yeah, that's why they're called the dog days, because it's Sirius. Okay, yeah, Sirius, they are. Okay, so anyway, so how have we been able to predict solar eclipses? Okay, so one of the things that was not needed was we didn't have to understand anything about how the sun, moon, earth, or the planets and stuff were related in space. We didn't know, whether the sun was in the middle, in the center, the earth was in the center, and that took all thousands of years to work out. 5.14 degrees actually for the moon orbit around the earth, or 6.7 if you count the 6.68 if you count the angle between the pole or the axis. Yeah, 5.14. Okay, very good. We know, in other words, today we know these very carefully, but we don't need to know anything. All we need to do is look up into the sky and to have a stick, basically, and something to measure degrees, which they knew about years and years ago, thousands of years ago. And that's all you really need to be able to, and a long lifetime, or several lifetimes, to be able to predict solar eclipses. Okay. So we don't have to worry about that. So I'm not going to show any of that. Now, all you have to do is have this. Really dark sky, since there wasn't any light pollution and stuff back then. Campfires, smoke, that sort of thing. But no light pollution. So the sky would normally look like this for most people. And of course, like I mentioned earlier, you don't have TV or phones or whatever to distract you. So a lot of people were able to go outside, see the sun, see the skies. And so these types of sites like here were normal back thousands of years ago. In fact, up until recent days when we had electrical lighting. Okay, but what they did see in the skies was there was 7 objects that wandered around. Yeah, the angles with respect to the ecliptic, which is what we call, is coming up here, the plane of the Earth's orbit. In other words, it's the orbit of the sun if you look up in the sky. And that's, in other words, think about being on the Earth without knowing about how any of this stuff is, that the Earth orbits or anything else. So there were 7 objects that wandered. That's what the term planet means wander. There were 7 objects that wandered through the skies at various rates. And of course, the sun and the moon were 6.68 lunar rotational axis with respect to the plane. And the sun and the moon were the most prominent. And then there were 5 other objects that wandered through the sky. Now, if it was a really, really, really dark sky, Uranus, the next planet out, is actually at the uh, and you had very good eyesight and it was dark, you could actually see it carefully because it's at just the magnitude that's at the um, edge of our seeing. And then people said, okay, well, if we're going to track these things, including the sun and moon and stuff, we need to have a reference point. And, you know, there's so many stars, thousands of stars that you could see, and some of them were brighter than others. Now, this particular view is from Australia, so for people in the northern hemisphere, everything's kind of turned upside down. So, in other words, Scorpio, this scorpion, normally you see it the other way. In other words, if you flip it or rotate it around, that's how we see it in the northern hemisphere. But this was in 2016, and you've got some bright stars there that are near, and so you could say, well, and then there was the what they called the now the name escapes me. What is it? Okay, where the why am I not remembering his name? Okay, where the all of the constellations go through the zodiac. Okay, so you have the what people determine as constellations of the zodiac. 12 of them that go through. Okay, so anyway, and I'll tell you why it's 12. Does anyone happen to know before I get there? Yes. Okay. Okay. So in other words, to know where these go through the sky, you kind of have to refer to the background stars. So here's the answer: is there's a couple things. If you go back a couple thousand years, there are a couple things that you need to know. One is that you're working in base 60, and then later on in Roman numerals, essentially, which are very, very cumbersome. There we go. Babylonians used base 60. That's right. Okay, and we still have remnants of base 60. Yeah, there you go. Okay, same thing. Oh, tag, good. And also, there's some evidence that other Mayans use base 20. There's some evidence that, for example, the Gauls or the Celts, for example, like in French, the 80, for example, is 80, which means 420s. So you still have remnants of base 20 showing up in numbering systems and such. But in any case, in English and other things, we still see the day divided into two sections of 12 hours, 60 minutes in an hour, 60 seconds in a minute. Oh, really? Yes. Okay. Also base 20. Good. Thank you very much. I appreciate it. I don't, to tell you the truth, my education, you know, was basically Eurocentric, and I would like to know a lot more about differences in different parts around the world, particularly in areas that were dominated by China. Okay, no planets. Well, okay, Sumo. Now here again, that could be an entire presentation in itself about the planets and the harmonies between the planets and the gravity and what they look like. In fact, you know, billions of years ago and all that stuff. Okay, Kepler's law, etc. Okay, when you're talking about rate, and they're also elliptic orbits and stuff. But in this day, think of it kilometers per hour, kilometers per hour. Okay, so think of it thousands of years ago when we didn't know any of that. We didn't know about, you know, Kepler's laws or planets or orbits or stuff. Okay, but in any case, the zodiac then was divided into 360 degrees, 60, you know, times 6 there, and then 12 sections of 30 degrees. The Egyptians actually had 36 sections of 10 degrees, which actually comes from as far back as the Sumerians and the Babylonians. Here again, I love calendars and things like that, and so I could easily do an entire presentation on that, but we're 25 minutes in, so I got to keep moving. And then the other thing to remember is that China, absolutely, with 12, and then you've got 12 animals in the zodiac. It happens to be the year of the dragon right now. And so the earliest astronomers also worked with whole numbers and ratios. In other words, they didn't have 27 or 5.14, whatever it was there. That numbering system didn't enter Europe until into a couple thousand years later. In other words, into the time period where you had both scholarly and military contact through the Arab world. Okay, so the Indians really had base 10, and then had the idea of the 0 and decimal places, which didn't really get well developed until the 600s and 700s CE. But angles, yeah, they knew pretty much about angles and all that good stuff and measuring long time ago. The other thing that we have to remember before we can start talking about how do you predict is the idea that there is an ecliptic, which we mentioned. The ecliptic is the sun's path through the sky. And then you've got the moon's path through the sky, which today we do call an orbit. I don't know what it was called a long time ago. But that the orbit of the moon is slightly off by 5 point whatever, or 5 degrees approximately from the ecliptic, but that it passes through the ecliptic twice a year, once every 6 months. That's going to become important here. So let's take a look at that. So given all these things that you could see in the sky, these relationships between things that you could see in the sky, just saying, well, fortunately, Tag, he was not living close enough to Rome for Galileo was, but, Kepler and Copernicus and others were living outside Prague, for example. Well, Prague was close enough, but then again, you've got the Reformation, okay? So in other words, he wasn't right under the thumb of the bishop in Rome. Okay, so one of the things they did discover, otherwise we wouldn't be having this talk at all, and there wouldn't be calendars, is that yes, but then, and we can discuss that also. But you're also talking about the Reformation, where you've got Catholicism. In other words, which holds sway? Do you have Protestantism or Catholicism? Where are people living, etc., like that? Okay. So anyway, one of the other things they noticed was that there were cycles. In other words, we know about the solar cycle, 365 and change. That goes around, and that's a tropical year, which everybody who lives more than a year discovers, and it is helpful in other words, the idea about the year, the calendar year, and affecting plants, unless you happen to live on the equator where there's not much difference, is important. The solar cycle. There's also a lunar cycle, but when you talk about a lunar cycle, and how long is a moon, it depends on how you're measuring it. If you're measuring it by the stars, that is when it passes the star Spica, which we saw, which was pretty much all close to the ecliptic. That takes 23 and a third days. Now, I'm not going 27 point blah, 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 because remember that back thousands of years ago, they didn't have decimal places and such. They thought of ratios. So 27 and a third days it takes in relationship to the stars, but because the sun moves in the sky, I'm trying to talk about the way they saw it, not the Earth going around the sun, but the sun moving in relationship to the background stars. The sun takes 29 and a half days to make a circle around the sky in relationship to the sun. And then if you're talking about passing the same node, in other words, going up or going down, or ascending or descending, as they would call it, across the same node of the ecliptic. It's in 27 and a fifth day because of the precession of the uh, um, of the lunar, let's see, precession of the it's not the precession of the equinox, not the precession of the equinox, it's precession of the where the sun crosses the ecliptic. Okay, that's probably too much anyway for right now. Okay, so anyway, so how often do these yeah, okay, so how often do these cycles repeat? Well, that was found out by at least 430 BCE, that the lunar cycle phases recur on. In other words, when do the lunar phases recur on the same day of the year? And they found out, well, that takes about almost every 19 years, or 335 synodic months. In other words, months relative to the sun. Which, how long, the average lifespan back then, particularly in the Roman days, was only about 25 years. So, in other words, it probably would have taken several lifetimes just to come up with that particular uh, uh, relationship. So, but the Metonic cycle, we know, was discovered at least back in there by a guy named Meton. Okay, but what about eclipses? What about solar eclipses? That's rare. Yeah, and then remember, it's not. Back in those days, they saw it as ratios. So 0.5 would have been something that came out, back in the 800s in India, and then not until the 12, 13, 14s, whatever, 15s in Europe. Okay, so when can eclipses occur? Now we're getting into the nitty gritty here. Well, okay, yeah. Well, you're right, and people did live long, and it depends on. Well, in front of me, yeah, old joke there, Tag. Okay, so anyway, and you're right. It depends on the moon and where it is, as far as it's because it's got an elliptical orbit, and where you lived, as far as, and also when we talk about living 25 years, that was just the average because a lot of people died um, before they were one. In fact, in some cultures, you didn't name the child before they were one because they were likely to die. 1 in 5, I think, died even in a couple hundred years ago in places like cities in Europe because of the. Okay, so anyway, but that's another presentation. Okay, so anyway, when can eclipses occur? Now remember, this is not something that people figured out mathematically, and it's not because they had models of the solar system. This is just observing the skies. Yeah. Now, Tag just brought up something which is important, is that shadows, of course, exist all the time. There's a shadow behind the moon right now. There's a shadow behind the Earth. There's a shadow behind everything up there from the sun. It's just that when does that shadow cross between it and the moon, or between the Earth and the moon, that sort of thing. And that's what, when we talk about solar or lunar, well, yeah, most people do. Okay. So anyway, there is a season, eclipse season, because the moon and sun are not dots in the sky, close count. So in other words, for about a mean of 34 days, roughly from 31 to 37, depending on the where the moon is in its orbit, because it can appear smaller or larger, whatever. The moon then has to be close enough to the ecliptic for the shadow of the moon to pass somewhere on the Earth. It could be, partial eclipse. It could be pretty close to the middle of the Earth, and so you get, and then the moon being a certain apparent size, you can get either an annular or total. Okay. If we got into the weeds of this, it would take a lot longer than an hour. So I'm just kind of brushing over some of the details of this. So, in any case, there's a certain period of time, about a month or so, every 6 months, when you have eclipses, and you're not going to find eclipses outside of that time period. However, if an eclipse, for example, appears at the beginning of that period, then there can also be another one that appears toward the end, because the moon only takes 27, 28 days to go around, and so it can literally go around twice in that 34 day period, or 37-day period. Okay, so how many eclipses can occur? Well, at least, Tag was saying they're rare, but they're rare in a particular place. In other words, for example, the Earth has 70% water. So there are eclipses that are going to occur. In fact, the next eclipse occurs mostly over the Pacific Ocean and can only be seen down in, I think, Chile toward the end of it. But in any case, most eclipses occur over the oceans. Sometimes you can actually find a voyage, a ship voyage. Yeah, and thank you for joining us. I appreciated your input, and you're welcome to join us again. Yeah, field trip to Chile. There's also ship voyages that go out to where the eclipse is going to be, if you're interested in that sort of thing. Okay, but so in other words, so a lot of eclipses occur over the water. The other thing is some of the eclipses occur near the poles, and they're very, very short. Some eclipses are only seconds in length. So in other words, not all eclipses going to occur near you. To clear right over your house is about every 300 years, or in the area about every 100 years or so, a century. So they're only a once in a lifetime type of thing. And yes, Tag is getting into the nitty gritty of the eccentricity and stuff like that. Okay. So anyway, okay. So, but every 6 months there's going to be at least one solar and one lunar eclipse. So but the ancients didn't know that stuff. They were able to work out some. But now, for a total eclipse, as I mentioned, the moon must be large enough to cover the sun. Otherwise, it's an annular eclipse. And if it's slightly off its orbit, it's just a partial eclipse. Okay, so let's move on. So what type of solar eclipse? Well, there's one more month, or one more definition of a month that we need to look at if we're going to talk about how often or how to predict total solar eclipses, or eclipses that look the same over a period of time. Okay, so the moon cycles from larger to smaller because its ellipticity, or obliquity, is that the better term, differs by about 12%. And you can see then on the left, or on the left there on the bottom, that's what 12% looks like. It literally looks bigger or smaller. And so it has to be a particular size in order to have a total eclipse versus an annular eclipse. So this is called the anomalistic month. In other words, from perigee to perigee, apogee to apogee. Well, that's exactly what I'm talking about with observational astronomers here, is what I'm basically talking about. A total eclipse of my heart. Well, actually, I know that song, so let's see, total eclipse of the heart. Okay, so an anomalistic month then is about 27 and a half days, and that's from, say, perigee to perigee. Well, I forget the rest of it. But I think I like the song. Okay, so now how often do these cycles repeat? In other words, how often can you have the same conditions? In other words, in this case, a total solar eclipse. In other words, the moon and sun in the same part of the sky, the moon crossing the ecliptic, and the same size moon. How often does that occur? Well, now this is something that they definitely took many lifetimes to figure out, because they discovered that after every 65, once you had a total eclipse in your area, or an annular eclipse, or whatever, is that, particularly total eclipse, is that 6,585 and a third days later, or 223 synodic, 242 draconic, 239 amethyst, was what's called one Saros cycle. What that means is the same conditions in the skies, crossing ecliptic, same size moon, all of that stuff occurred every 6,585 days. Now, what does that third of a day imply? What that means is, and I'll show you some illustrations here. By the way, I've told people before is that when I have presentations where I don't have a lot of illustrations and pictures, it means I was somewhat rushed to get it done. So, on this one, I was a bit rushed to get it done. But whatever, we're here. So I have to talk my way through it. Okay, so a third of the day is 8 hours. What that means in terms of the Earth moving is that the next eclipse of the same type, in other words, a Saros cycle, will occur a third of the way around the globe, or 120 degrees. And so in 3 Saros cycles, you'll have the same type of solar eclipse occurring near you. So, for example, in in 54 years and 34 days, there will be another total eclipse somewhere on the same longitude of Texas in April 8th, okay, which is where I am, or anywhere where you are, same thing, 54 years, 34 days. Now, it won't occur over the top of you because, and we'll talk about that here in a half a second. Let me move on. Okay, so total solar eclipses. Yeah, long period of comets. And yeah, when we talk about comets and stuff, now we're getting, well, you're right. And I looked that up. You know, Dolly, as far as 1970, and I looked it up, and I put in the exact date. I go, okay, total eclipse in Texas in North America or whatever, 1972, and there was, you know, or 1970 or whatever it was. I forget what the exact date is. But if you put that in Google, you'll actually see, yes, there was at that time period. Okay, so now long term. Okay, yeah, many centuries for comets, and sometimes with the hyperbolic, of course, never. As we all know, Halley's Comet showed up in 1910. Mark Twain announced it, and then, of course, it showed up later, because I can remember when it showed. 86, absolutely. I can remember when seeing it in 86, and then it's going to be past my lifetime when it next shows up. Okay, so when was the secret known? In other words, that it took a certain period of time for a Saros cycle, and then 54 years, which was beyond the lifetime for a lot of people back in the Babylonian days, for example. When did they have this information? Well, you know, the Babylonians weren't the first astronomers. And in fact, the first astronomers were, of course, anyone looking up at the sky. But the Sumerians knew about it. That was one of the first civilizations, and the Chinese knew about it. You know, Mayans knew about this sort of stuff. But in any case, in Babylon, they discovered the Saros and then what's called the exoligmos cycles by at least 600 BCE, and then passed it on. Remember that the Greeks, in terms of Alexander the Great, conquered this area in the 330s to 320s, took about a decade. And then they learned this stuff from back in those days. So when you say Greek astronomers, like, for example, Seleucus was actually born in the Babylonian area, and he believed in a heliocentric, in other words, with the sun in the center, and then there was another guy named Aristarchus in Greece who also said, hey, you know, this would heliocentric. Also, you know, explain most everything if you actually put the sun in the center. But then a lot of their works were not kept, particularly probably after the burning of the library in Alexandria. But you had Plato and Aristotle, who was his apprentice, and then I think Aristotle was the one that talked to Alexander, or taught a young Alexander, and those people that basically, nah, the Earth's in the center and they're perfect spheres and stuff, and so that carried down to. I'm actually going to talk about the Antikythera for the thing in just a second, and then Ptolemy and all those people, and so basically that all took another 1,500 years to resolve. That in the days of Kepler and Galileo and all that stuff like that. Okay, so anyway, the Antikythera mechanism then actually had the Metonic cycle and the Saros cycle on them. And so we know that the Greeks had that by that time. Okay, so let's now skip ahead a couple thousand years. Or be burned at the stake or whatever they did in those days. Being decapitated was actually for royalty, etc. For the most part. A lot of times they just burned you. People. Okay, so anyway, now we're skipping ahead by a couple thousand years to today. So in summary here, remember that they were good at, you don't have to have a telescope to be able to predict a total solar eclipse. What you have to have is real, nice one, Dolly. Okay, so what you had to have was simply a stick, something that measured degrees, and then be very patient and have a logbook and track the sun and track the moon and track when eclipses happen, and then pass this information on to someone because it's going to be many lifetimes until you perfect this stuff. Well, tag, that's actually another, since we can't actually ask or have them write it down, that's actually another discussion. Okay. So anyway, did what? I'm following some of the presentation here. Okay. So anyway, yeah. Okay. Oh, to see if he blinked his eyes? Yeah, okay, but this is really getting off the subject, so I'm gonna wait until we get back on it here. Okay. So anyway, yeah, that's okay. Anything in chat is fine. It's fair game, particularly humorous stuff. Okay, that way I know everybody's out there doing stuff. Okay, so anyway, skipping ahead a couple thousand years to now. So what else do we know? Well, we've got the base 10, we've got the decimals, we've got the timepieces, we've got the telescopes, all that. So we know that these months, literally, and that's good, you know, scientists to the end and beyond, is that we know these months, the synodic month, the draconian month, the anomalistic month, to very, very precise, you know, fractions of a second. Because, and why is that important? Because these are still the relationships today. If we know the exact values of those months, what we're talking about is when the sun and moon are in the same longitude. We're talking about when the sun and moon, when the moon crosses the ecliptic, in other words, the path of the sun. In other words, when they cross each other's path at the same time, like a car wreck. Yeah, a sidereal, tropical, etc. In other words, okay. And then we also know about the when they're in the moon is large enough. In other words, at apogee, perigee. Yeah, Aquarius. Oh, speaking of which, hey, Arj, let me just bring that up because I'm watching my time here, and I'll be okay on the time. Is if we're looking at this and the zodiac and stuff like that. Now remember, and I think I have some of this information. Yeah, there we go. In fact, I got it on that slide. is the idea is that the uh, if you're in an Aries, you're not really an Aries. In other words, because of the precession of the equinox or the wobble, is essentially some of that's changed. So, that, in other words, where the North Star is has changed, so that the zodiac is also different than it was back when astrology was first invented, and so we have everybody has progressed by another sign. In other words, the astrological signs are actually off from astronomy, and so you had the Beta Ursa Minoris, in other words, the second brightest star in Ursa Minor, as the North Star up until 500 CE, and then by the way, from 500 CE to 2150, it's going to be Polaris will be the closest to the North Star, and then it will be another star after that. And so in other words, another brighter star will be the North Star. So the age of Aquarius, by the way, actually starts when you say sing it, Polaris. So when you talk about the age of Aquarius, that actually doesn't start until 2150 on the calendar, et cetera, et cetera. I love calendars, by the way. I've done presentations on calendars, so I could so you could talk about this. Now, remember though that okay, remember though that everything over time changes. In other words, the length of day changes because the moon is slowing down the Earth. The moon, the distance to the moon changes. So in other words, the apparent size of the moon is changing by about a centimeter a century. What that means then is that there was a time long, long ago, probably a billion years or whatever, where there was no annular eclipses. It was all total eclipses. And 600 million years from now, there'll be no total eclipses because the moon will be too far away. Everybody go, oh. You know, not like this. Whoops, what is it? Hang on a second. Yeah, that sort of thing. Drat. Okay. Of course, I'm not going to be around. And then also the eccentricity of the orbits, even the star positions themselves are changing. The other thing is, and here again, I can't go too much. I've got to make sure I finish on time here. Let me go to the next one. Okay, so anyway, how does all this apply today? Is that, but even something like the big earthquake in the Indian Ocean back in, what was it, 2004? And then the big earthquake off of Japan much more recently actually changed the length of the day by a tiny fraction of a second, millionths of a second sort of thing. Oh, okay, cool. I'll take a look at that. Okay, so anyway, the modern Saros cycle actually began fairly recently. In other words, they didn't label some of this stuff until 1955. So the actual Saros cycle is a misnomer. There was as we know, and you saw it in the Antikythera device and stuff, there was a cycle of 223 synodic months, which was what we call a Saros cycle. But a SAR was actually a period of 3,600 years. Edmund Halley, is it Halley? I didn't think of Halley, but I say like Halley's Comet, so Halley's Comet, but whatever. The same guy that the comet there found a reference to it in Halley. Yeah, that's how I pronounce it. Okay, so in a Byzantine scholar text back in the 1000s, whoever the scholar was mistakenly linked the name to the biblical cycle of 20, or Babylonian cycle of 223 months. Okay, so anyway, have a Holly, Jolly. Okay. Okay, so the name stuck. In other words, we stuck with this thing called the Solar Cycle, which is not what the Babylonians would have called it. Okay, so in any case, there was this pivotal textbook or text that came out in 1955. It basically said, okay, let's look at these series of Saros cycles. And so Saros cycle 0 was set back to 2955 BC. No, that should be, yeah, BC in 1955. And then there are actually quite a few Saros cycles going on right now that the eclipse all looks the same in those Saros cycles. That's what the series is all about. So you have everything from Saros cycle 117, which will end in 2054 with a eclipse near the poles, and I'm trying to remember whether it's North Pole or South Pole of the Earth, through 156, which began so now I'm going to give you an illustration here, so this doesn't, so in other words, I don't put you to sleep unless I already have, which are active right now. So there's going to be, like I said, a total eclipse across North America on April 8th, and it's actually part of what's called Saros cycle number 139. Well, I thank you for your confidence scorings there. Okay, so this makes more sense. Okay, look at this one. So what you have here is that, remember I said that every Saros cycle, there will be an eclipse that looks almost the same, that occurs 120 degrees west, in this case, of the eclipse, of the eclipse that, whoops, my watch is talking. Okay, so eclipse, the last eclipse that looked the same. So in other words, one Saros cycle, 120 degrees, you're going to get the same one, and then the same one 54 years later. So say, for example, look at the one in the middle that says 1919. By the way, does anyone know what that one's a very famous eclipse? Does anyone know? May 29th, 1919. Does anyone know what the significance of that one is? That's a very famous eclipse, total eclipse. Yeah! Ted, got it. Okay, yes. In other words, yes. And in this case, instead of the special theory of relativity, general theory of relativity. Okay, so in other words, they went to South America and they looked at it, and Einstein had predicted that this bright star would be able to be seen at the periphery of the total eclipse on the sun, but it would be off by about, what was it? There was a degree, not a degree and a half, it was a fraction of a degree or something. And in other words, the light was bending around the sun, which was the prediction. And lo and behold, they saw that it was able to be seen when it shouldn't be, and it was bending around the sun, and that's how you're able to see it. And so that actually was a proof of Einstein's general theory of relativity in 1919. By the way, he didn't get because theory of relativity was still pretty new, he didn't get a Nobel Prize for general relativity. He got it for the Brownian effect, I think is what it was. Yeah, there's a movie on it. Okay. Gravitational lensing, exactly. Okay, so the other thing is, notice that this was a graph. I think this is kind of a cool graph. 8,000 solar eclipses, all graphed by what's called the Eclipse cycle and the Saros cycle. And so notice the pattern of partial eclipses out there, the total eclipses, the annular eclipse. Eddington was the guy that went out there to check the eclipse and then came back and report, yeah, he did it. Okay. Well, the axes are what are called the Saros cycle and then what's called the Eclipse cycle. Now, the Eclipse cycle is where the eclipse is on the same longitude but opposite latitude. Okay, but they also think that the Aubrey holes, the holes around Stonehenge, are a combination of Inix if it's cycle, and half a Saris, or a total of 1,385 fortnights, which a fortnight is one half of a Saris. And if you got all that, okay, the color code is orange is partial, total, purple is total, and annular is green. And then you also got some hybrids when you got that. Yeah, it is. It's beautiful, and it also shows the regularity. Okay, so this is my last. I've been an hour in. This is my last slide, and so this is what the total eclipse looks like on April 8th, passing right over my house, right in the middle, with the amount of the sun that is covered, with those blue lines, and then the hour which it occurs and where it starts and stuff like that. And so basically my bottom line, since I'm right now exactly an hour in, is that with a combination of ancient discovery of the relationships of solar and lunar cycles, in other words, like the moon and the sun, the year, and our modern understanding of the relationship of the sun, moon, earth, and then accurate measures down to many, many decimal points, we can tell exactly and predict exactly for hundreds of years when there'll be an eclipse, where it'll occur, what type, how big is the path, all of that stuff like that. And that's all due to thousands of years of observational astronomy and to modern instruments and all that stuff like that. So that's my presentation today.